this music for a minute. Fuck this music for a minute. Sorry. So you just inherit some kind of methods, arguments, and every shit. Like you mean, see, just not bad, no. Well, no. Let me show you one thing. I'm sorry, I don't have any fucking expensive things. I just draw with my trackpad. Uh, Damn, I forgot. Okay, so let me draw. Uh-huh. Draw. Click on the pencil. Yeah. See, if this is Papa, I mean Daddy. Uh, this is his little lick. So the characteristics and the all personality and everything, like everything, just are gonna inherit to his child. Am I right? Oh, that's a big hand, bro. What are you gonna do that with hand? Are you gonna jerk it? So this is dad. So dad's characteristics and personality characters and everything or shit is going to inherit to his child. This is inheritance. So now let's go to the topic. I'm closing this shit. Tell me. Sorry, that was my bro. He's retarded. He's retarded, dude. The fucking coffee is so cold, bro. What this guy has said to me is like something shit. Just let me explain it in my own way. I'm just trying my best, bro. Um, so inheritance is nothing but inheriting the arguments and methods and your shape. As I said, I'm sorry for repeating these many times because I don't fucking know what the fuck to say right now. Just let's run it. Oh, good. So this is the main class. You are inheriting this class in this fucking dog class and this fucking cat class and this fucking rat class. See, when you keep this animal, what do I say this? Like something Pascal's word or something, yeah, class name. In this dog's class name as an argument, you are gonna inherit all this shit to dog's class, and even in including this, or what do you call this? Yeah, cat and rat. So if I ever wanna call some name or ears of a dog or cat or rat, I don't need to fucking type here that define init. Uh, Go ahead, this motherfucking keyboard. Fuck, sorry. Self name year, and again I need to self name equals to name self year. Oh shit, sorry man, I didn't see the screen. So you no need to type like this shit because you're inheriting all the content and arguments from the animal class to the dog class. So I'm just passing this class, and because if you don't pass this and if you just left, there's gonna be error left over like this. So I'm just passing because I don't know what to write in this. Just leave it aside. Uh, Damn it. Bro, this fucking coffee. I just how do I say this, bro? Like I just poured 10 spoons of coffee in a small mug of coffee mug. And this tastes like a hell, bro. It's so yeah. My fucking flavor taste is so disturbed in my mouth. Sorry for my English again. I know my English is trash, but I'm just trying to improve by like this. I know no one is watching my stream, but at least I'm gonna talk to myself and get improved for somewhat anything. So just let fucking go. So this is inheritance, bro. And this guy said something. Yeah, let's call even this. You guys know, yeah, just let me explain what is class variables and instance variables. So class variables are the variables which are declared outside the constructor. Here, constructor means this, initiate. This fucking dunder is known as constructor. Just let me say this. Constructor. So, I mean, just remove this, bro. So this initiate, this underscore underscore initiate define, this shit is known as constructor. So the classes which are declared and defined outside a constructor are known as class variables. So what is the use of these class variables? These class variables are used to, I mean, use in any object. See, if you ever declare something in this constructor, these are actually known as instance variables. So if you use instance variables and declare inside the constructor, you only use them in specific objects. So if you use class variables, you can use these fucking class variables in any object. So this is the concept between class variables and instance variables. So I'm just want to declare some, what do you say this? Class variables. Dogs, animals. What is related to animals? Dog, cat, rat. Dog, hamster. Let's give this hamster. Hamster, 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 hamster. Yeah. Uh, why did I give hamster? Because they are friendly. Dogs, cats, hamsters are friendly. And I'm gonna give this, it's nothing but, oh, damn. Calm down, nigga. Oh, okay, cool. Yo, bro, what's wrong with you, man? Okay, fine. Uh, so friendly, sorry, friendly animals equals to 0. So if I declare these funny animals like animal dot friendly animals plus equals to 0, sorry 1, it's gonna increment. So like see, I'm just gonna print this. Print. I'm gonna use a string here like a sentence, small sentence. What are the friendly animals the uh, the friendly animals are animal dot friendly animals for, and they are um just let me take this x and print here. You know what, guys, I don't have any fucking privacy in my home. I don't even have a PC. I just have using my laptop, and this isn't even used to gaming, bro. This use it as laptop. I'll just show you my specs. See, 128 GB graphic card, Intel Iris Xe 16 GB 447 MB. See, i5 12th generation, use it is. Bro, what the fuck do I do? It's okay, fine. I'm happy with what I am because at least I got this shit. So just let's run this and make this shit. Okay, run this. Oh damn, bro. What the fuck, man? Class hamster. Friendly animals equals to 0. Hamster dot name. Oh, sorry, bro. Hamster. Hamster. Sorry, 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 sorry. Yeah. See, there are. The friendly animals are three. What are those? Dog, cat, and hamster. And their names are, sorry, Scooby, Billy, and Mosey. Fine, I got this shit. And another shit
for
I
every
need to
single.
learn here.
Imagine if you have hundreds of
Inheritance.
classes. That's going to take a lot of work. It's a lot easier to write the code once and then reuse it, and I only need to make that change in one place, rather than make that change many times. So let's change is sleeping to is asleep, and see if that works again. Mickey is asleep. Let's replace mouse with dog. Scooby is asleep. Not only that, but with children classes, they can have their own attributes and methods that are different from one another. So dogs have all these attributes and methods, and they can speak. Let's create a speak method, and I will print a unique message for dogs. Woof. Cats will also have a speak method, but it's going to be different. Cats will meow. Then for our mouse class, they will squeak. Let's have our dog speak. Woof. Let's have our cat speak. Meow. And our mouse. Squeak. Alright everybody, so that's an introduction to inheritance. Inheritance allows a class to inherit attributes and methods from another class. Much like in real life, a child can inherit traits from a parent. These are also known as sub and superclasses, which is a topic for another day. Inheritance helps with code reusability and extensibility. If all of these children classes inherit these attributes and methods from another class, we only need to write that code once and not copy it for every single class that needs it. We can write and change the code in one place for better reusability and extensibility. And well, everybody, to inherit attributes and methods from another class. Much like in real life, a child can inherit traits from a parent. These are also known as sub and superclasses, which is a topic for another day. Inheritance helps with code reusability and extensibility. If all of these children classes inherit these attributes and methods from another class, we only need to write that code once and not copy it for every single class that needs it. We can write and change the code in one place for better reusability and extensibility. This allows a class to is asleep, and see if that works again. Well, now I need to find every single sleep method and change it manually. It's not too bad if you only have a few classes, but imagine if you have hundreds of classes. That's going to take a lot of work. It's a lot easier to write the code once and then reuse it, and I only need to make that change in one place, rather than make that change many times. So let's change is sleeping to is asleep, and see if that works again. Mickey is asleep. Let's replace mouse with dog. Scooby is asleep. Not only that, but with children classes, they can have their own attributes and methods that are different from one another. So dogs have all these attributes and methods, and they can speak. Let's create a speak method, and I will print a unique message for dogs. Woof. Cats will also have a speak method, but it's going to be different. Cats will meow. Then for our mouse class, they will squeak. Woof. Let's have our cat speak. Meow. And our mouse. Ability. In with multiple inheritance. That's when a child class
So guys, this is it about inheritance. There's nothing much about inheritance. I mean, this is the fundamentals, basics of inheritance. Um, that's it for this video. I mean, sorry, I'm not a big YouTuber to tell like this, but according to my knowledge, I gained from this shit video. I mean, this is not a shit video. This is actually ultimate W video. I like his channel and I like this guy. I always go through his channel whenever I get any doubts regarding any CS major doubts. Yeah. So this is the end of inheritance. I mean, the fundamentals of inheritance. Let's now, what the fuck, man? Now let's go to multiple inheritance. So what about this sheet? This sheet is actually something called as about basic concepts of hoops. These are attributes, these are objects, these are shit arguments, bro. There are no fucking methods here. Uh, yeah, let's go through methods again. So methods are nothing but the actions done by such a class. If you ever take an example of car, see this is a car. What can a car do? It can go, it can stop, it can brake. Yeah, these are the methods, and you can do them like define, brake. Oh damn, bro. Henry like something I brake at point of speed breaker. Yeah, or the stop marker, etc. So this is about methods arguments and the shared objects, and this is about class arguments and inheritance variables, and this is about inheritance. Sorry, this is instance variables. So okay, let's go to next topic.
Inherits from more than one parent class. For example, a class of C can inherit the traits from both class A and B. A class when a child class inherits from more than one parent class. For example, a class of C can inherit the traits from both class A and B. In Python, you can have more than one parent. Multi-level inheritance we'll talk about near the end of this topic. So in this example, we're going to create two parent classes, prey, I'll write pass for now, and predator. We'll create a class of rabbit, a class of hawk, then class fish. Rabbit, hawk, and fish are going to be children classes. Prey and predator will be parents. If one of these classes, rabbit, hawk, or fish, inherit from prey, they get the ability to flee. We will define a method of flee. All we'll do in this example is print the following text. This animal is fleeing. If you're a predator, you get the method to hunt. Define hunt. We will print this animal is hunting. Rabbits, they will inherit from the prey class. They're typically not predators, except that one rabbit in Monty Python and the Holy Grail. That's the exception. Rabbit will inherit the prey class. Then it gets access to a flee method. Hawks are predators. They will inherit the predator class. Now fish, they will hunt smaller fish and flee from bigger fish. You could consider fish both prey and predators. So they will inherit both classes. We will use multiple inheritance. They will inherit everything from the prey class and the predator class. Now let's see if this does in fact work. Now we'll create a rabbit object. Rabbit equals rabbit. There are no parameters set up. We don't need to send any arguments to the constructor. Hawk equals hawk. And fish equals fish. So let's take our rabbit object, and they should have a flee method. Rabbit.flee method. This animal is fleeing. But they do not have a hunt method because they're not predators. Rabbit object has no attribute hunt. Hawks can hunt. They're predators. They inherited that method. This animal is hunting, but they can't flee. They're not prey. Hawk object has no attribute flee. Fish can do both. They inherit from the prey class, and the predator has no attribute. Hawks can hunt. They're predators. They inherited that method. This animal is hunting, but they can't flee. They're not prey. Hawk object has no attribute flee. Fish can do both. They inherit from the prey class and the predator class. Fish.flee. This animal is fleeing. Fish.hunt. This animal is hunting. Children classes can inherit from more than one parent, which is what we did for fish. They are both prey and predators, whereas in rabbits are just prey, hawks are just predators. If you need to inherit from more than one parent, you just add that additional class to the inheritance list. With multi-level inheritance, a parent can inherit from another parent. We will create a class of animal. And for now, I'll write pass. Prey and predator are going to inherit from the animal class, so we need to add animal to each inheritance list. Let's say if you're an animal, you get a method to eat. All animals will eat. Print this animal is eating. And you can sleep. Define sleep. Print this animal is sleeping. So think of rabbit, hawk, and fish as children classes. Prey and predator are those classes' parents, and animal is the grandparent. Prey and predator will inherit everything that the animal class has. Rabbit, hawk, and fish will inherit everything the prey and predator classes have. So now our rabbit, hawk, and fish classes should have the ability to eat and sleep. And we'll test that. Rabbit.eat. This animal is eating. Rabbit.sleep. This animal is sleeping. Let's check out fish. Fish.eat. This animal is eating. Fish.sleep. This animal is sleeping. Okay, we're going to expand upon our example a little bit. Let me zoom out. Each of our objects is going to have a name. Our rabbit will have a first name of Bugs. Hawk will be Tony, as in Tony Hawk. Our fish will be Nemo. Within our classes, we don't have any constructors set up. In which class should we assign the name attribute? Let's do so within our animal class. So we will define a constructor to assign these attributes. We will receive a name. We'll assign self.name equals name. Now with these other classes, if you're not assigning any attributes, or if you don't need any other initialization logic, you don't need a constructor. We'll implicitly use the constructor we inherit from the parent. Let's convert each of these print statements to an F string. Replace animal with self.name. Now let's have our rabbit use the eat method. Oh, we should get rid of this. There we go. Bugs is eating. Rabbit.sleep. Bugs is sleeping. Rabbit.flee. Bugs is fleeing. Let's check out our hawk. Hawks don't have a flee method because they're predators, not prey. Let's eat. Tony is eating. Let's sleep. Tony is sleeping. Let's hunt. Tony is hunting. Let's check our fish next. Our fish can eat. Nemo is eating. Our fish can sleep. Nemo is sleeping. They can flee. Nemo is fleeing. And hunt. Nemo is hunting. Okay, everybody, that is both multiple and multi-level inheritance. With multiple inheritance, a child can inherit from more than one parent class. You just add each additional class to the inheritance list. With multi-level inheritance, a child can inherit from a parent, which inherits from another parent. Class C can inherit from B, where Class B inherits from A. Think of C as the child, B as the parent, and A as the grandparent. C will have all the attributes and methods, even available within the grandparent class, of A. And well, everybody, that is both multiple and multi-level inheritance in Python. Hey, everybody. So today,
Bro, I think you got understood by this multi-level, sorry, something multi-level or multi-inheritance. It's nothing but inheriting the characteristics or arguments or fucking methods, anything shaped from grandparents or parents or to child, like just ecosystem in the nature. So let's get through an example right now as quick possible. So let's take cable of just a minute, bro. Sorry for the distance. Just a minute. Let me inherit the. Oh yeah, let's take an animal. Sorry for the disturbance again. Sorry for the disturbance. Uh, what do you define here, bro? Define in it. Oh damn, bro. Self common name. Let's give it a name. Self dot name equals to name. Now let's go get another class like predator. Yeah, predator. Is this the fucking name? I mean spelling. Yeah, let's go. Print. I hunt. Um, no. Okay. Love hunting. Fine. Let's go to another class. Prey. I surrender. Surrender. Yeah. So now let's go to class rabbit. Rabbit is a prey, right? So let's give it a prey. Pass this shit. Let's go to eagle. It's a predator, bro. Predator. And fucking pass this shit. Class of fish. Sorry. Hey, yo, bro, I think I gotta have a capital letters here, right? Remember, this is a Pascal's class, something I forgot what do I call them. But remember, having a capital letter before starting a class name is better for further purpose. So, fish, and it's a prey and predator. So, pass. Let's define what do animals do. Define. Um, what do they do, bro? Eat? Yeah, they eat. Yo, they are ordered in this fucking animal class, bro. They eat. Oh, damn, bro. They eat. Mm, self dot animal. No. Self dot name. Oh, fucking hell, no, bro. What do animals do, bro? What do animals do, man? Come on, bro. Go through predators or animals. Animals. And preys are also animals. Animal. Yep. Self dot name. Eats and define sleep. Print uh, self dot sleep. Sorry, name sleeps. So now let's. Oh damn, bro. What the fuck is this, bro? Now let's say rabbit equals to rabbit function and it. What do I say? This shit, man. Yeah, I should give a name because you see here a passed an argument of name and it's so crucial to give this name because if you didn't give this name, it's gonna get an error like let me show you this. See this sch others yes arguments is failed. So let's go to here and give it a name as quick, really quick. Mm, Ruby, Ruby Chan. Yeah. Sorry for that. And now let's go for eagle. Eagle equals to eagle. Sorry for the noise again, bro. It was just a mistake. Yo, 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 bro. What's happening here, bro? Eagle. Ruby-chan. Yeah. Nani Kasuki. Bro, what's other name, girl? What's the name of other girls? Ruby-chan. Names. Ruby-chan and Nani Kasuki. I just trying to explain what means Ruby-chan. Bro, what are the names, bro? Names of Ruby-chan characters. Yeah, Ruby. Ayumu. Yeah. Let's give it an Ayumu. Sorry, Eagle. USA. USA got rice better. Fish equals to fish. Um, Shiki-chan. Shiki. It's perfect, bro. Let's go. Let's go. Now, rabbit dot is rabbit a prey? Let's see. Oh, bro, chill, man. Damn, bro. Something is fishy. Oh, let's give it Hun. No, bro, something's fishy, man. Let's give it predator. Rabbit dot predator of animal. Just a minute, bro. Sorry, bro. It was my mom. Uh, yes, anyone watching my live? I know no one's gonna watch my live. I know this is me, bro. This is me. I just opened my phone and watched my stream for a second, whether if it's going good or wrong. Fine. It's okay. Nothing matters, bro. Everything matters right now is my development, bro. How far am I going from doom scrolling to edge smashing the employment? Let's go, buddies. So, Predator, why is it not? Bruh, what the fuck do I need to do, bro? Just a second, I forgot this syntax, man. Ruby-chan, Nani Kasuki, fish sleep? No, it doesn't sleep, bro. Prime Predator, come on, bro. Gravity got soon. Rabbit, birds, Tony, Nemo, Hop, eat. Oh, damn. These are classes. I forgot about this. I need to define something. Predators to hunt. Oh, damn, man. Okay. Self dot name. I need to pass in a string, I think. Yes. Slash self dot name. Self dot predator. Predator. No. What's wrong with this, bro? Why do you need to import self here, bro? Let's go self dot name. Okay, I got it. So if you're importing self from here, this self from here, you can pass this argument to this shitty thing. Oh damn, what the fuck is this? So that you can call the name of this to here and this predator to here and here and a prey to here. I think, let's see. Def self hunt. This doesn't hunt, this gives up gam. Do you guys love gambling, bro? Let's pass on a string. And what's this name, bro? Dot name. Chill, bro. Self. Self. Okay, let's pass it now. Bro, what the fuck? Oh, sorry. Pray. Function. Let's go. Bro, what's wrong with this guy, man? Predator.
There we go. Bugs is eating.
Rabbit. Dot E. Bro, what the fuck? Why is this nullifying? Self. Self. Animal. It's already an animal, bro. What the fuck do I need to do this? Is that an indentation error? Yeah, it's an indentation error, man. See, how the fuck I can write a function in a function, dude? Let's run it again. Bro, what the animal eat takes zero positional arguments, but one was given. Its name. Animal eat function takes zero positional arguments. Uh, let's give self. Yo, bro, what's wrong with this man? Oh, okay. I didn't pass the F string, bro. Sorry. My fucking ass, Ruby. Yeah. Rabbit eats. Rabbit predator. Okay, fine. I gave up, bro. Rabbit hunts. Bro, what the fuck? What's wrong with you? Predator. Who the fuck turned on the AC, man? Oh shit, nigga. Bro, how the fuck do I say this? How does it hunt? Oh no.
Class. A class of animal. And or just prey,
Rabbit.flee.
the predator class.
Hog.flee. No. Okay, fine. I got it. But yo, it's disgusting as fuck. So rabbit to hunt or rabbit to flee? Yo, come on, man. Hunt versus gives up. Yo, bro, just a minute, bro. I'll be back. So hi guys, sorry, I'm just back. So let's see if it runs. Bro, what's wrong with here? On gives up. Let's try gives up, bro. If it works, fine, or else. Yeah, gives up is working. Yeah, it's working because here it is a prey for the animal of these functions and arguments. Yeah, and now let's try this. What's Ayumu? Ayumu with hun. Damn, bro. Yeah, it works. See, here's the argument error. Ar Argument error. Rabbit object has no order attribute. What is attribute? Arguments, attributes, arguments, attributes, arguments, attributes. Just a minute. Class attributes, arguments, class variables, attributes. Oh, shit. I was thinking attributes and arguments are the same structure in this code. So it's my fault. Sorry for again. So now let's go to another topic, which is like super function. No, multiple. Yeah, that's it, bro. Let's go further.
Fish.
I'm muting myself and going with system audio. Okay, guys.
Dot flee. This animal is fleeing. Fish. Dot hunt. This animal is hunting. Children classes can inherit from more than one parent, which is what we did for fish. They are both prey and predators.
Every
Whereas in
resource
rabbits are just prey. Animal is eating. Hey everybody. So today I got to talk about the super function in Python. Super is a function. It's used within a child class to call methods from a parent class. The child class is the subclass. The parent class is the superclass. Hence why this function is named the super function. Using the super function, it allows you to extend the functionality of the inherited methods. Here's an example. We'll create a few shape objects. We'll need to set up the classes though. We'll have class, circle. For the time being, I'll just write pass. We'll fill it in later. Class, square, and class, triangle. For each of these
See, 16 GB 447 MB. See, hi-fi 12th generation U series. Bro, what the fuck do I do? It's okay, fine. I'm happy with what I am because at least I got this shit. So just let's run this and make this shit. Okay, run this. Oh damn, bro. What the fuck, man? Class hamster. Friendly animals equals to 0. Hamster dot name. Oh, sorry, bro. Oh, sorry, bro. Oh, sorry, bro.
classes, in order to instantiate objects, we'll need a constructor. We will define our constructor, our init method. When creating circles, what sorts of attributes should a circle have? Let's say a color. What's the color of the circle? Is it filled or not? Filled will be another attribute, and a radius. Then let's assign these. Self.color equals the color that we receive. Self.filled equals filled. Self.radius equals radius. Let's do this with the square and triangle. Really, I'll just copy our constructor and paste it. Squares don't have a radius. With a square, the width and the height are the same. Let's replace radius with width. We'll also keep the color and filled attributes. Self.width equals width. Now with triangles, again, let's copy our constructor. We'll need a width and a height. Self.height equals height. So with programming, we try not to repeat ourselves if we don't have to. What do all of these classes have in common? They all share the attributes of color and filled. The ways in which they are different is that circle has a radius attribute, square has a width, triangle has a width and a height. If we have to make any changes to one of these attributes, we would have to do so manually. For example, let's replace filled with is filled. Now I need to look throughout my code for any instance of filled and replace it with is filled. It's a lot of work, and I might make a mistake, such as here and here. It's better to write your code once and try and reuse it. So that's where inheritance and the super function can come in handy. We're going to take the attributes of color and is filled and place it within a parent class. These children classes will inherit those attributes. So class, what do they all have in common? They're all shapes. Class, shape. And for now, I'll write pass. Circle is going to inherit from its parent of shape. That also applies with square and triangle. we'll set up a constructor for shape. Define init. We will pass in the color and isFilled. Then we will assign these attributes. Self.color equals color. Self.isFilled equals isFilled. We don't need to manually assign these attributes within each of these constructors for the children. Instead, what we have to do is within the constructor for each of these children classes, we have to call the constructor for the parent, also known as the superclass of shape. So we will eliminate these two lines of code, use the super function, dot, call the constructor of the parent, and that is the dunder init method. But we need to pass in the color that we receive and isFilled. This will be a Boolean. Then let's do this. Self.isFilled equals isFilled. We don't need to manually assign these attributes within each of these constructors for the children. Instead, what we have to do is within the constructor for each of these children classes, we have to call the constructor for the parent, also known as the superclass of shape. So we will eliminate these two lines of code, use the super function, dot, call the constructor of the parent, and that is the dunder init method. But we need to pass in the color that we receive and isFilled. This will be a Boolean. Then let's do this with the square class and the triangle class. We still need radius for the circle, width for the square, width and height for the triangle. We're going to call the super function to take care of whatever attributes all these types of shapes have in common, such as color and isFilled. Now let's see if this works. Let's construct a few objects. We will create a circle named circle, call the constructor for circle. We have to pass in a color, a Boolean if it's filled or not, and a radius. So for the color of the circle, let's say red. isFilled, let's say that is true, and a radius of 5. You could even use keyword arguments for better readability, although not necessary, but for clarity, let's say color equals red, isFilled equals true, radius equals 5. Let's see if this works. I will print our circle's color. It is red. Print our colors isFilled attribute. The circle is filled, that is true. And the radius. Print circle dot radius. The radius of the circle is 5. We could even convert this to an F string. I'll add a placeholder, then add centimeters. 5 centimeters. Let's construct a square object. Square and a width. I'll just count. The color will be blue. isFilled will be false. The width, if we ever need to out our square width. The width is 6 centimeters. The color, 7. Let's print our triangle is yellow. It's filled in. The width is 7 centimeters. The height is 8 centimeters. So that's how you You can use the super function to reuse the you can use the super function to reuse the
Hey guys, Roy. Just forgot to unmute my mic. So, what do circle have? Let's say color. Mm, fair. Uh, I don't think. Yes, circle have already. Yes, right? Yeah, let's do this here now. Definite self color here and self dot color equals to color self dot field equals to fair. So let's fuck this all here. Bro, come on, man. Super function dot init. Bro, what? Self color field is, am I right, guys? Oh, damn, bro. So why do I need this? I think I can eliminate this, right? Oh no. Okay, fine. Cool. Chill, bro. So I need to define like self dot radius equals to radius plus square square. What? Chill, bro. So class is filled here. Yo, bro. Come on, chill, nigga. Self dot width equals to width. I forgot to change this width. And now class triangle. Yeah. It has like what does it have? Height and this and super. These are defined, bro. These are defined. These are important from super initiated classes. This is super class here. So I don't need to fill this again here. See, this is why these two were just basically highlighted and these are hardly highlighted because these are implemented and came from here to here. Yeah, it's just inherited like simply in simple words. Self dot I h equals to h. Now let's call circle equals to circle in big words like color, right? Fill true. Radius 5. Triangle square. Square equals to square of blue. Yo, blue. False. Oh damn right. False. 3. Triangle. 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 Yellow. True. 4 and 3. 4 and 3. 4 into 3. 4 to 3 is going to be 6, bro. The answer is going to be 6. So now let's print this. Circle dot radius now. I think we need to circle dot radius. Yes. Let's see if it no. Object initiate takes only arguments the instance is initialized. Bro, radius. What the fuck, man? Color circle. Bro, what's wrong? Circle dot color function. What the hell? Circle dot function color from shape. Should I say like it's shape dot circle dot color? Oh, what the fuck, man?
So within our shape class,
So,
let's create a method of describe. We will describe the attributes of this shape. We will print, use an f string. When we want to describe our shape, let's say it is, add a placeholder, self.color. What is the color of this shape? And is it filled or not? And add a placeholder. We'll use a ternary operator. Print filled if
if
self.is filled is true. Else we will print not filled. Each of these types of shapes, circle, square, and triangle, will have access to a describe method. Let's attempt to use it.
bro, where? Who the fuck wants describe, bro? I don't want this fucking describe. I want this fucking initiate or color. Print triangle dot color. Oh, I should print. Okay, cool. Print triangle dot color. Use function. Nigga, what? Bro, come on, man.
Our
It's fill. Yo, bro. Triangle dot height. Mm-hmm. Bro, what's wrong with this team, motherfucker?
triangle is yellow, it's filled in, equals.
I mean, I just got a doubt like, why do these guys need these keyword arguments? So, okay, let's try keyword arguments. If it works, it works. Color, fill, and radius. color, fill, width, color, fill. Oh, 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 cool, 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 cool. Height, pace, chill, nigga. Let's try now. Bro, what's wrong with this? Drag with monster ball. Circle equals to circle, color equals to red fill. What the fuck, man? I'm calling triangle. Bros. I don't know what's wrong here, dude. This fucking charger isn't working well right now. I actually did ChatGPT every day. I take it on a date. I fuck with it. I do everything. Is there anything wrong I did here? Yes, there's an issue in super class. I think the syntax error, bro. It's a syntax error. See, niche color. No, this works correctly. Inherit from shape. I did it. Oh, damn. So should I inherit this shit? Damn, bro. Shape, shape, shape. What a fucking creep I am, bro. What a piece of shit. Color. So just like, let's call this like triangle dot color. Let's check if it works. Now, string object is not callable. Why? Okay, let's call ready base. Int object is not. Bro, why? In super and using of super is the show. This is what I get. Call trying to call attributes. Attributes. Your base is an attribute. Bro, what the fuck? So I even call here. So oh, so here I call the just let me Hamster, class dog animal sleeps. Bro, what the fuck? How lengthy is this code, bro? No, 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 no. Just some error. Rabbit predator eat two animal. Yeah. See, if you take an example from this code, you're calling an method, not an attribute actually. You see? Just a minute, guys. It's spinning as hell, bro. Oh, fuck. It's spinning as hell. I actually got a, what do I say that in English? Something known as like pus former lump. A lump with pus. Lump with pus. Yeah, lump with pus. It's killing my bro. I got it actually on my under my stomach. It's seriously paining as hell, bro. I can't able to sit properly. I can't able to walk. I can't able to move. I can't able to sleep. Bro, it's paining. Even if nothing is touching to it, it's paining as hell. I don't know why. Ouch. Yes. Let's go, guys. It's okay now. Let's start this session. Let's complete this shit. So see, here you're calling this fucking hunt, bro. Hunt is a function, bro. See, this is a function. You defined it. And this is a fucking argument. See, if you call argument directly from like hunting, no. Pray. Pray is an argument, no. There's nothing argument here, bro. So there's a name. Eagle name. How do you call this fucking eagle name, bro? Just tell me. Eagle name. Damn. It's hunt. You hunt it, man. You hunt. Love hunting. I didn't notice this until now, bro. I haven't noticed this until now. Fine. At least we learned it now. So now let's don't call base. Let's call some shape or triangle or function init super. What the fuck do I need to call, man? Is color a attribute? Yes. Str object is not callable. String object. Color is an attribute, a string, not a method. So we need to call a method. Correct way, no parenthesis needed. What's the difference between this and this? And triangle dot color. What's the difference between these? I mean, what? Great question. My teachers never say this word, bro. But this ChatGPT and Copilot bot, this is just awesome, bro. They appreciate our work and our questions and our doubts and everything, and they prolong with this prompts. The difference comes within attributes and methods. Okay, print triangle of color. The simply asks attribute. This simply accesses attributes color of a triangle object and prints its value. Okay, since color is just a variable, holding a string, you don't need parentheses. Okay. Oh damn, bro. Just simply just I'll just explain you in simple words. No, 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 no need of this. See, if you ever define a function like function hello. Return, no, print hello, motherfucker, just for fun, bro. And you need to call this as hello. That's it. Oh, damn, man. See, you'll get an output of hello, motherfucker. If you get this shit, hit again, return. See, you'll get oh, nah, damn, nigga. Hello, return. Now, uh, just say a plus b. See, you're calling a function here, dude, because it's actually function. You're not asking the shit, bro. Come on, man. Sorry, nigga. A comma b and a plus b, and you're calling here attributes. What are those attributes? 2 comma 6. What's the output? 4. Oh, damn. Return 2 comma 6. Bro, what the fuck, man? Yo, what's wrong here, bro? Return a comma b. Print hello. And a plus b. Nigga, what? Bro, I'm cooked. I'm cooked as hell. Bro, come on, man. I just want to show you some trick, bro. So, what's wrong here? Just a small issue. What's that issue, bro? Result is equals to hello and you. Oh, damn. Result equals to hello of function 2 comma 6 and print. No, that's not 6, bro. It's actually 6. Sorry. Yeah. See here, you're asking for this fucking, what are you? Attribute. This is an attribute. This isn't function. If you want to call the function, you'll just write this. Yeah, this. But you're calling an attribute, kind of attribute variable. Sorry. So when you're calling an attribute and other variables, you use print function. But when you're calling a method, you use this shit. This is fucking satisfying, bro. So color is an attribute. Print. What's a triangle color? Hello. What's a triangle height? 4. What's a square width? What's a square width? 3 or 2? Yeah, 3. Good. So this is about superclass, and the syntax for superclass is super dot initiate color and fill. This color and fill are from this superclass. This is the superclass shape, the parent class, and you initiated this here, and you just don't need to initiate. Sorry, don't need to call again here. You just can pass this super method of function here, here, here. So this is about super. Let's go with another thing.
Let's check out our square within each of the children classes. We can do that in just one place. When we refer to super, imagine that we're replacing this with the parent class name, such as shape. That might be a good way to think of it. Use the constructor of the parent class of shape and pass these arguments in. What you could do as well is extend the functionality of a method. So within our shape class, let's create a method of describe. We will describe the attributes of this shape. We will print, use an f string,
Bro, guys, I'm gonna show you one baddie, super baddie. I like her for real. Where is she? 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 Yeah, I just saw her pic on my phone, and I just want to show to you guys. She's a baddie for real. I like. Damn, she's. I can't express, bro, but I like her. See, there. This is you. I don't know, but I like her, bro. She's like mommy. Russian mommy. I think is she from Russia or daughter of Sweden. Where is Sweden, bro? Where is Sweden? Sweden's my country, North. Oh, damn, bro. Sweden. I thought she's from Russia. Is Sweden in Russia? No. I know it's no, but I'm just mad, bro. Europe map. Where's this? Oh, I got this shit here. Okay, Sweden is here. Okay, fine. She's from Sweden. Anyways, I like Europe. I love Europe. I love Sweden. Damn, bro. W for real. Goth? Oh, Gothenburg. Sorry, I thought it's. Are they, let's say, are they Goth mommies in Gothenburg? Sorry. Oh, damn, bruh. Uh, there. Damn, bro. Let's go, man. It's likely there are mothers within the Goth subculture in Gothenburg as the. Damn, bro. W. Who the fuck is this guy, bro? Tattoo artist. Hey everyone, I'm a suburban tattoo artist in Gothenburg savings. Oh, is this guy who gets tattoos on Goth mummies? Lucky motherfucker. Damn. Woman in Gothenburg. Let's see. Gothenburg female population has been subject to various research studies focused on society specific. Whoa, damn. Bro, these don't look like goths. Damn. Mm, okay, fine. Okay. Uh, let's Visit a random place in Gothenburg. W for real. What's this, bro? What's this store? Milo. TK Mechaniska. What the fuck is Mechaniska, bro? Is that a mechanic shit? Yeah, lunch. Bro, what's this language, bro? Is that what language do um Sweden people? Yep. I think it's Swedish. Swedish alphabets. 29, 26 standard Latin. What the fuck was this, bro? A, B, C, A, B, C, D, E, F, J, H, I, J, K, L. What the fuck was this, bro? Damn, we're diverting, bro. Let's end this here. By the way, we love her. We love her. We love her. No, 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 no. Fuck.
Okay, okay, okay.
It's fine, it's fine.
What the bro? What?
Do you have any ibuprofen? I got a headache. It's fine, it's fine.
You just try.
Do you have any ibuprofen? This place is
Moscas and my boyfriend. Yeah, I'm sharing. Oh, nice. Send me a picture of your hair up and spec. Are you trying to hop on a game? What are you playing? Right, I'm gonna say 896. W, bro. W. Nigga, are you high? Waka. Waka.
She like me around my niggas. She teed up,
God.
she not switching. G6 got me in here glitching. Real rich as fuck, just living. This bitch ain't.
I think you guys understood. Like, got my feed. This is how fucked up my feed is. What's the time right now? Oh, damn, it's 7:03.
The functionality of a
We just got diverted from Python to got mommies. And Instagram brain rot again, bro.
method. So within our shape class,
What did this guy do? Like, this guy did something, bro. He initiated
shape, if
describe.
filled. Within our circle, let's calculate the area. What's the area of the circle? I'll use an F string. It is a circle with an area of, then we'll calculate the area given the radius. To calculate the area of a circle, we can take pi, I'll just say 3.14 just to keep it simple, times the radius squared, self.radius times self.radius. If I were to call the describe method,
I'm just gonna mute myself, bro. Sorry for the disturbance.
will we use the parent's version of describe or the child? So let's take our circle, use the describe method. The result? It is a circle with an area of 78.5. I should really add centimeters squared after that. Centimeters squared. This is called method overriding. If a child shares a similar method with a parent, you'll use the child's version and not the parent's. This is method overriding. If you would like to extend the functionality of a method from a parent, you can use the super function. Not only do I want to use the describe method of the child, I would also like to use the describe method of the parent. So within this function, we will use the super function. Access the the describe method of the parent. What we're doing is extending the functionality of the describe method. It is a circle with an area of 78.5 centimeters squared. The circle is red and it's filled. Or you could change up the order. Let's use the parent class's describe method and extend the functionality with our own print statement. It is red and filled. It is a circle with an area of 78.5 centimeters squared. Let's finish this with the square and triangle classes. I'll copy what we have for the describe method within the circle class, but we'll make a different calculation. Describe the square. It is a square
How many minutes? Very few. But you offered me a kiss. Why?
Such a foolish reason, I'm afraid. I just wanted to kiss you.
tell you that I loved you if I did. It's so strange deciding how to feel about it. Such strange emotion standing there beside it. I'm home with moonlight on the river, saying my goodbyes. Home, there's moonlight on the river. Everybody dies. I'd say, see you next time. If I thought there were a next time. Easy conversation ain't exactly where we're at. It's so strange deciding how I feel about you. It ain't like I ain't used to going on without you. Home with moonlight on the river, saying my goodbyes. I'm home, there's moonlight on the river. Everybody dies.
Function in Python. What is going on, everybody? So today we're tacking on another print statement. Before that, to extend the functionality of the integral, let's describe our square. It is a square with an area of 36 centimeters squared. It is blue and not filled. let's describe our triangle. It is a triangle with an area of 28.0 centimeters squared. It is yellow and filled. Alright everybody, that is the superfunction. It's used in a child class to call the methods from a parent class, also known as the superclass. It allows you to extend the functionality of the inherited methods. Within a child class, you could use it within a constructor as color or functionality on polymorphism in Python. Polymorphism is a programming concept. It's a Greek word that means to have many forms or faces. Poly means many. Morph means form. In programming, an object can take one of many forms. There's two ways to achieve polymorphism. One is through inheritance. An object could be treated of the same type as a parent class. There's also duck typing, which we'll talk about in the next topic. In this video, we're more focused on inheritance. What we'll do in this video is create a class of shape. We'll write pass as a placeholder. We will create a class of circle, which will inherit from shape. Again, writing pass. Class square inherits from shape. Class triangle, which inherits from shape. If I was to create a circle object, circle equals circle. Our circle identifies as a circle, and since our circle class inherits from the shape class, our circle is also considered a shape. It has two forms. It's a circle and it's a shape. But our circle isn't a square or a triangle. That could also apply to our square class. Our square is a square. Our square is also considered a shape, but our square is not a circle or a triangle. Those are two possible forms for our square. It's a square and a shape. So let's say we would like to create a list of shapes. What do they all have in common? Well, they're all shapes. A descriptive name for this list would be shapes equals an empty list. I will instantiate a circle object, a square object, and a triangle object. Our circle is a circle and a shape. Our square is a square and a shape. Our triangle is a triangle and a shape. Each of these objects has two forms, or two faces. Let's fill in some of these classes. Let's say that with our shape class, we will define an area method. Define area. I'm going to turn this into an abstract method. I'll just write pass. To work with abstract classes, we need to import that. From ABC, import capital ABC, as well as abstract method. Preceding the area method, I will add a decorator of abstract method. Our circle, square, and triangle classes, they're all considered shapes. They inherit from this class. We need to define an area method for each, since they're all considered a shape. Every shape has an area. With a descriptive name for this list would be shapes equals an empty list. I will instantiate a circle object, a square object, and a triangle object. Our circle is a circle and a shape. Our square is a square and a shape. Our triangle is a triangle and a shape. Each of these objects has two forms, or two faces. Let's fill in some of these classes. Let's say that with our shape class, we will define an area method. Define area. I'm going to turn this into an abstract method. I'll just write pass. To work with abstract classes, we need to import that. From ABC, import capital ABC, as well as abstract method. Preceding the area method, I will add a a decorator of abstract method. Our circle, square, and triangle classes, they're all considered shapes. They inherit from this class. We need to define an area method for each. Import capital ABC, as well as abstract method. Preceding the area method, I will add a decorator of abstract method. Our circle, square, and triangle classes, they're all considered shapes. They inherit from this class. We need to define an area method for each, since they're all considered a shape. Every shape has an area. With our class of circle, let's define a constructor. Define init. We will pass in one argument, a radius. What is the radius of the circle? Assign an attribute of radius equals the radius we receive. Let's do this with square. Define init one parameter, the length of a side, self.side equals side. Then triangle. Define init. We have two parameters, base and height. Self.base equals base, self.height equals height. Alright, now let's finish defining these area methods for each class. We will return self.radius. That's how to calculate the area of a circle. We will to the middle, return self.base times self.height times 0.5. Now we have to pass in some arguments. For our circle, we need a radius. I'll pick 4. For the square, the length of a side will be 5. Then our triangle, the base will be 6, the height will be 7. We're going to write a loop to iterate through our shapes. For every shape in shapes, then we're going to print for every shape, call the area method. And that would give me these numbers. If you would like, you can format the output. I'll just use an F string. I'll add centimeter squared. Much better. What if we were to create a class that's completely unrelated to shapes? I will create a class of pizza. I will define a constructor. To construct a pizza object, we need a topping and a radius. What is the radius of the pizza? Self.topping equals topping. Self.radius equals radius. Within my list of shapes, I'll add a pizza object. But I have to pass in a topping, such as pepperoni. And what is the radius of the pizza? Let's say 15 centimeters. So our pizza class doesn't have an area method. Here's what happens when I run this. We get an attribute error. Pizza object has no attribute area. Our pizza object is considered a pizza, but it is not considered a shape. It does not inherit from the shape class at the top here. You know what? A pizza is circular. It could be considered a circle. So how about this? Let's take the pizza class. It will inherit from the circle class. And within our circle class, we're already assigning the radius to the radius attribute. So instead of doing that here within the constructor for our pizza class, let's call the superconstructor super, which refers to the parent, use its constructor, then pass in the radius we receive. Let's see if this works now. That does. Here is the area of our pizza. Our pizza is considered a pizza. It inherits from the circle class, so it's also considered a circle. And our circle class inherits from the shape class. Our pizza has three forms. Our pizza is considered a pizza. It's also considered a circle, and it's also considered a shape. It would make sense for it to fit into this list of shapes, because our pizza also identifies as a shape. So that's polymorphism, everybody. It's a Greek word meaning to have many forms or faces. Poly meaning many, morph meaning form. In Python, there's two ways to achieve polymorphism. One through inheritance. An object could be treated of the same type as a parent. And there's also duck typing, which we'll discuss more in the next topic.
Welcome back, aliens. My name is Navin Reddy, and let's continue with the series on Python. Now we have started talking about objects, right? And we moved towards class, and then we have discussed about inheritance. Now it's time to focus on one of the major concepts in OOPS, which is polymorphism. Oh, that's a weird word, right? Now when you talk about polymorphism, let's break down this word poly and morphism. So poly means many, right? And when you say morph, it means forms. So that means one thing can take multiple forms. Example, like as human, we have different forms. As the situation changes, we change ourselves, right? Example, we behave differently at different location. At office, we behave differently. When we are with our friends, we behave differently. So we are polymorphic. In the same way, when you talk about object-oriented, objects will have multiple forms. So this concept is very important when you talk about software development. So we use this concept a lot when it comes to loose coupling, dependency injection. We also have a concept of interfaces, which we'll see later. There are four ways of implementing polymorphism. The first one is duck typing in Python. The second one is operator overloading. Then we have method overloading and method overriding. In the next few videos, we're going to talk about all these topics, okay? And one of the interesting one is duck typing, especially if you're coming from different background. Let's say if you have already seen Java or C++ or C#, this is a bit different for you, because in Java or in C#, we have to mention the type of the variable which you work with, right? We have to mention the type of object you work with. But
What's up, you guys? Welcome back to another Code with Kylie video. Polymorph goes like Wacos, everything like this. So once I've defined all of these, I'm going to initialize them. Of course, we have to add self in there. And let's say for simplicity, we're just going to give all these dogs a name. So self.name equals name. And this is going to go through all of these like this. Right off the bat, you can see that we have the same initialization function literally copy and pasted 3 times. In addition, if we had another function like likes walks. And of course, all of our doggos like wacos, so we are going to paste these everywhere. So what we're seeing here is a lot of code repetition because these 2 functions are basically copy and pasted for all 3 of these dogs. If we take a step back and we think about this in real life, well, Samoyeds, Poodles, and Golden Retrievers, they're all a breed of dog. So what we can do in Python is we can actually add a parent class to all of these classes, which unifies them as that type of object. We can create a superclass called dog, which basically would have all the properties and functions of a dog to share among all of the breeds. So here we can say init, and then we can give it even other things like age, friendliness, etc. And here let's do self.name equals name, self.age. We're just initializing all of these attributes within our class. All the doggos like the wacos, so we're doing likes walks self. And this is true. Okay, so now that we have the superclass, remember what we said about how inheritance basically allows the child class to inherit from the parent class? All we would have to do is classify our 3 breeds as child classes of dog. And how do we do that? Here in our class definition, all we have to add is parentheses, and then within the parentheses, the parent. So here we have Samoyed, and then this basically means Samoyed is a child class of dog. And here we can even erase this. And of course, we would input the name, age, and friendliness, but then down here, instead of reinitializing the exact same thing, we don't have to copy and paste that code. Instead, we can just do super, and this means call the superclass dot init. So here this is saying in the superclass, call this initialization function, and then we're going to pass in the parameters that belong up here. So that's name, age, and friendliness. And then I'm going to do that with all my doggos down here. And change these so that they are now subclasses of dog. Ta-da! Alright, so let me just show you guys how this works. You can see that in Samoyed, we haven't defined likes walks. But if I create Sammy the Samoyed, and I pass in a name, so Sammy, an age, 2 maybe, and then friendliness, let's do a scale 1 to 10, let's say 10. Let's say that Sammy is 10 out of 10 friendly. Okay, so now what we can do is we can print Sammy dot name Sammy.age and Sammy.friendliness. Okay, so we see that for Sammy, we get that the name is Sammy, the age is 2, and Sammy's friendliness is a 10 out of 10. So here, this initialization function has actually called this one up here to set the attributes. Okay, so one other cool thing is we can actually print Sammy.likeswalks. And again, we haven't actually defined likeswalks as a method under Samoyed, but we have in the superclass. And now you can see that it will actually inherit from that superclass, so we can actually call this function likeswalks. Okay, so look, it's true. We can actually call likeswalks Set the attributes. Properties from parent classes, and then multiple inheritance means that you can actually have more than one parent where the subclass will inherit from. Talk a little bit about polymorphism. Now, what in the world does polymorphism mean? Polymorphism quite literally means the ability to take multiple forms. From an object-oriented standpoint, this actually means that a child class that inherits a function from maybe the parent class can override that function and give that from an quite literally means the ability to take multiple forms. From an object-oriented standpoint, this actually means that a child class that inherits a function from maybe the parent class can override that function and give that function a completely new set of rules to follow. So again, let's do an example with our dogs. Under our dog, maybe we can define our bark. All dogs might bark like woof. So we can return woof as our bark for all of our dogs. And that's just our default bark. Okay, so we have Sammy and all of our bark like. Let's just see what their bark would sound like. Okay, so we're printing Goldie's bark and Sammy's bark. And both of them are woof. But we can actually change this for subclasses and make the subclass follow a different set of rules. Come down here and I define bark. This is polymorphism because we can actually override this and we can say arf arf maybe. Whereas maybe a golden doodle is saying something like aroo or something, I don't know. Now let's listen to these dogs barks again. And just for comparison, I'm gonna create a new dog object. Generic doggo equals dog, and I'm gonna name it Jean. It's gonna be 10 years old, and of course I'm gonna say this generic doggo arf arf, and this generic doggo goes woof. Override. Because it's in the subclass and we've given it new instructions, ignore the parent instructions and follow these instructions instead. So for any type of function that's even more complicated, we actually don't look at what the parent has. And this function now takes a new form, polymorphism. So these are kind of all the building blocks of object-oriented programming. With inheritance and polymorphism, we can get rid of repetitive code and organize our classes better. And we can also have the flexibility to change any of the functions to make sure that they are actually doing what we want from a lower class. How cool is that? Anyways, thank you guys for all joining me for my beginner
Stay tuned for that. And well, with our triangle, define area, return self.base times self.height. Circle, let's define self.class. Return self.base. I'll pick 4 to iterate. Then we're going to print and that would give me these numbers. I'll add centimeter squared. Much better. What if we were to create a class that's completely unrelated to shapes? I will create equals top. Is super considered a circle, and so today I got to talk about duck typing in Python. Duck typing is another way to achieve polymorphism besides using inheritance. Objects can be treated as if they're a different type, as long as they meet the minimum necessary attributes and methods required of them. It follows this adage: if it looks like a duck and quacks like a duck, it must be a duck. As long as an object resembles another, it could also be treated of that type. So in this example, let's create a class of animal. We will have a class attribute of alive. If you're an animal, you will have an attribute of alive. You're a living creature. Let's create a class of dog. The dog class will inherit from the animal class. They will inherit the alive attribute. Let's also define a speak method. If you're a dog, you gain the ability to speak. We will print woof. Then we'll create a cat class. Class cat inherits from animal. For the speak method, we will print meow. Let's create a list of animals. What do these two classes have in common? They both could be considered animals. Let's create a list of animals. We will construct a dog object and a cat object. If I was to write a for loop, for every animal in my list of animals, have each animal use its speak method, which will result in the dog going woof, the cat going meow. They're both speaking. What if we add a class that has nothing to do with animals? Like class car. Cars will have a horn method. That's how they speak. When you honk the horn, you will print honk. Within my list of animals, let's create a car object. It really doesn't belong in here, but let's see what happens. We have an attribute error. Car object has no attribute speak. Our car object doesn't have the minimum necessary attributes and methods. When iterating through this list of animals, we're calling each animal speak method, which our car object doesn't have, but it does have a horn method. So what if we rename our horn method as speak? Maybe it's an AI car or something. Well, this would work. The dog goes woof, the cat goes meow, the car goes honk. So our car object, it quacks like a duck. We could consider it a duck. It has the minimum necessary methods to be considered an animal. Animals inherit this alive attribute. Let's utilize that. After the animal speaks, let's print their alive attribute. Print my animal's alive attribute. My car object doesn't have that attribute. We get an attribute error. Car object has no attribute alive. But if I was to add that attribute, alive equals false, we have true for the dog, it's living, true for the cat, it's living, but false for the car, it's not living, it's not a living creature. My car meets the minimum necessary requirements to be considered an animal. If I were to set this to be alive, well then it would be a living car, kind of like the movie Cars. So with Python, duck typing is another way to achieve polymorphism besides using inheritance. As long as an object has the minimum necessary attributes and methods, you could treat it as a different type of object. If it looks like a duck and quacks like a duck, it must be a duck. And well, everybody, that is duck typing in Python. Hey, what's going on, everybody? Today I'm